Now we're going to talk about the second facet of measurement that's important, which is reliability. And so if you remember, reliability is sort of the right-hand side of that basic measurement diagram, and it has to do with the how large or what amount of random error there is, which I'll illustrate shortly. But another good way to think about it is the consistency of a measurement. A reliable measurement is a measurement that would give you the same result when you apply it to the same object or person or event. So it's sort of the notion of measure twice and cut once. If it's a reliable measure, the two measurements should give you fairly consistent results, and unreliable measurement will give you rather inconsistent results, even though it's measuring the same thing. So consistency is a good way to think about reliability. How consistent is the measurement from if you repeat the measurement process? Now, we talk a little bit in the book about what might cause noise in the measurement of poverty. It has to do with things like how the survey is conducted and the data are processed, but I'll let you take a look at that on your own. Here's a diagram that shows the idea of reliability as being related to the amount of random error in a measurement or noise. So you can think of this as sort of a signal to noise kind of issue, where in a measurement with good reliability, most of the way in which a number is high or low, or a measurement varies, is determined by the signal, the indicator, the measure itself, and not by the noise. Whereas in a situation where there's poor reliability, the number is more, the data is more driven by random errors. There's more noise in the data and less signal, and in some ways, this is the way in which researchers sort of think about reliability as the kind of the amount of random error that is reflected in their measurement. Now, the reason reliability matters is because it introduces more variability in the data, which has some consequences. We'll talk first about averages, and sometimes we use measurements to calculate averages, percentages, or means. If there's a lot of random error, the means themselves are not that affected, but what happens is the confidence intervals, the precision of the data is compromised. So here's a graph showing you means, which are the dots, and then the bars show confidence intervals, and you can see that as you go from no errors to small errors to large errors, the confidence intervals get much bigger. And so one consequence of poor reliability is a lot of larger confidence intervals, and therefore less statistical precision in a way with the data. Related to that is an important fact that unreliable data tends to water down or attenuate relationships. So what you're looking at here are three scatter plots that show a relationship between x and y. In the first part of the scatter plot up here, we're assuming there's no error and the relationship is nice and strong. If we begin to add error into x and y, notice that the scatter becomes more widespread, and there's an attenuation or a flattening of the line. And if we get to this bottom scatter plot with a lot of error in both x and y, the dots become really scattered and the line becomes much flatter. And so this means, in a sense, that if there's a real relationship in the world, you may be missing it because of poor reliability in your measurements. So, for example, let's say air pollution. We're interested in the relationship between air pollution and heart attacks in urban areas. If we have air pollution measured with a lot of random error, and if we had the rate of heart attacks measured with a lot of random error, there may be a real relationship there that we don't detect, that we don't find because our measurements are not reliable enough. So reliability has consequences because it can lead us to miss things that, if we have unreliable measures, we may miss things in the world that are important to know. Okay, so just like with validity, there are strategies for assessing reliability. There are empirical strategies. One is directly related to the definition of reliability. we can test something and then retest it. So test two measurements, or conduct two measurements of the same thing, uh, measure the same thing twice, and then examine the correlation. So we might assess the reliability of a reading test by giving it twice to the same group of students within a short period of time, let's say a week, so that there would not be reasonable that they would learn a great deal more in the time in between. Or we could, if we're interested in the reliability of a basic home thermometer for measuring body temperature, we could just measure it twice and see how closely the two readings are. So that's called test-retest reliability. We can also, many measurements are carried out by raters and people, research workers who rate things. And we might be interested in how consistent the research workers are, how their measurements compare if they look at the same thing. So we might have, let's say, two people, two different raters rating the quality or the cleanliness of streets in a city. They may be walking around with clipboards and rating the cleanliness of streets and sidewalks. We could have the same two raters rate the same street and see how consistent they are. So the street hasn't changed, the reality hasn't changed, and we might be interested in how reliable or consistent the raters are. And sometimes that's used to train people so they become more reliable and they rate things in a similar way. That's an interesting example because it gets to the notion of the reliability of scales. We talked about, for example, the self-esteem scale, which has 10 items. And one way to think of the reliability of a scale is how consistent the items are in rating the same person. So we can think of almost the 10 items as if they were raters of the same person, and we can look at the correlation or the relationship between the items. This is probably one of the most common types of reliability assessments you'll see in most social and policy studies. It's referred to sometimes by a statistic called Cronbach's alpha, and it's basically the average of the what are called sort of split half kind of correlations between items in a scale. And a Cronbach coefficient is a general measure of how intercorrelated the items of a scale are. And finally, there's another kind of reliability that has to do with sometimes measurements involve multiple forms, like there can be several versions of an English language test because you don't want the same test from year to year. And there's a question of whether the forms are reliable. They're meant to assess the same thing, but the forms need to be changed, obviously, because you don't want to keep reusing the same test. But then there's a question: are they still measuring the same thing? Are they reliable?